Hello, and this is Sunny. Welcome back. Today my topic is pulse code modulation, or PCM, a method used to convert analog signals to digital signals. PCM consists of 3 steps: sampling, quantizing, and encoding. PCM may sound very complicated because it involves many big words, but it's actually a very simple process. Let's say the first step, sampling. As we know, analog signal is continuous over time. It looks like this if we draw a graph to represent an analog signal wave. Let's take this segment as an example. Suppose this segment represents a 1 second long telephone call. Sampling is a process of finding a sufficient number of samples so that original signal can be represented by those samples completely, and it should be possible to reconstruct the original signal. Let me explain the sampling with this graph. The red continuous line is original analog signal. These vertical blue lines are samples. Samples are basically discrete values of amplitudes with a regular interval over time. That's why the process of sampling is also called PAM, pulse amplitude modulation. PAM signal is simply the result of a series of these discrete sample values. The number of samples per second is called sample rate. In this example, the sample rate is 34 times per second because this 1 second long analog signal is sampled 34 times. We use hertz to measure sample rate. For example, 1 sample per second is 1 hertz. 1,000 samples per second is 1 kilohertz, and 1 million samples per second is 1 megahertz. You may ask, what's the standard sample rate in analog to digital conversion? Great question. The answer is, it depends. For telephone, sample rate is 8 kilohertz or 8,000 samples per second. For voice over IP, the sample rate is double, which is 16 kilohertz. For audio CD or MP3, sample rate is about 44 kilohertz or 44,000 samples per second. For very high quality sound, such as a Blu-ray disc, sample rate can be close to 1 megahertz or 1 million samples per second. We can see in this example, 34 samples over 1 second would be far from being sufficient, but I think you got the idea. Now let's move on to the second step, quantizing. If sampling is like drawing vertical lines, quantizing is like drawing horizontal lines and then make each sample match one specific horizontal line. Let me explain the process. Sampling converts a time-varying signal into a discrete time signal, a sequence of real numbers. Real numbers are any number you could find on a line segment. 10 is real number, 10.002 is real number, and 10.0021325 is a real number. On any line segment, we can find an infinite set of real numbers. However, we only need a finite set of values which can be converted to binary numbers. Quantizing process exactly serves this purpose, but how? Here I want to introduce a new term, bit depth. Bit depth means the number of bits in each sample. The most common bit depth in analog digital conversion is 8-bit, 16-bit, or 24-bit. 8-bit depth has a 2 to the power of 8, or 256 possible levels. 16-bit depth has a 2 to the power of 16, which is 65,536 levels, and 24-bit depth means 2 to the power of 24. It is about 16.8 million levels. In this example, let's use 8-bit depth to measure our samples. It means there are 256 levels, and each horizontal line represents each level, and each level is associated with a specific bit value. Quantizing process is the process of rounding off the amplitudes of flat top samples to a manageable number of levels. We try to make each sample to match each level because each level has a specific bit value. Now we are ready to encode these samples with 8-bit depth. Let's look at the sample at the very top level. We can see it would match decimal number 255, which is equal to binary number 1111118 ones. The sample at the very bottom would be aligned with a decimal value 0, which is 0000080 zeros in binary. Thus, any sample matches a different specific level with a specific binary value. In coding step, we will convert each sample from right to left in time order to specific binary numbers. From 1 second analog data, we can get a long stream of zeros and ones. From 10 minutes telephone call, we can imagine we can get a really long stream of zeros and ones. In summary, sampling converts a time-varying signal into discrete time signal, a sequence of real numbers. Sampling is like drawing vertical lines with a regular interval. Quantizing process is like drawing horizontal lines, and each line has a specific measurable bit value, and they make each sample flat top match the specific horizontal line. In this way, each sample can be uniformly encoded with the specific bit values. I hope this video is helpful. Thank you very much and see you next time. Oh, don't forget to subscribe.